So Rames Awad from Fraunhofer IPA. I'm responsible here for the group assembly automation. And what I will be presenting is the temporal heat maps. The idea for this software module started actually in a sister group. They are responsible for navigation on demand. So basically AGVs cooperating with each other, running in the factory. And they noticed in one of our customers that during lunch hours, the AGV performance drops. And they were providing remote support. They were unable to find out why. Everything was functioning fine until someone actually went to the factory and looked at that hour in the day. And what they noticed is that, okay, the corridors where the AGV was supposed to run, there were a lot of humans going around there. And of course, when humans are around, the AGV speed drops due to the local safety control loop. And because of that, the performance was not so good. So in essence, it's summed up here very nicely. Sometimes the shortest path between 2 points for an AGV is the long way around in order to avoid the human and maintain the high speed. And what we wanted to do is, okay, we said that it makes sense actually before starting such AGV projects for logistics to first elicit the data about the foot traffic inside the factory. And we said, okay, we need to gather that data. So our idea was to put some leaders at intersections and to basically collect that data, aggregate it in 1 hour intervals and see like, okay, which corridors are at certain time slots in the workday are free. The AGV can run at high speed, or like where are there a lot of foot traffic, the AGV would actually slow down. So let's avoid routes taking those corridors at that point in time. We actually implemented, so we are using LiDARs as the sensing technology. It was basically to avoid any data protection issues. With LiDARs, we cannot distinguish between persons. And what we do is we aggregate the LiDAR information in a cost map. We used for this the ROS cost map. We adjusted a little bit. And we aggregate that information, send it through the Orion context broker to a Mongo database. The Mongo database stores that information, and you can use that information afterwards. What we are also doing is we are publishing the current heat map at any point in time. So not aggregated, it's just like one real-time heat map. We did some experiments in our lab. So you see here a little bit like our first prototype. This is our current prototype for the LiDAR. So you see the LiDAR here. Inside, you have a Raspberry Pi for processing and also for sending the information via wireless. It's all connected to a master node that collects all the data, aggregates it, and sends it through the cloud to the database. What we are using is Ubuntu 20.04 and ROS Neotech. It's all Dockerized, so you actually don't need to worry about that. And you see here like one example from our own lab. This corridor here, never used, can be used for AGVs without a problem. This corridor here, because here we have a cell that needs a lot of maintenance. You see that a lot of people are working here, so our AGVs would probably try to take this corridor and avoid this corridor at any cost to be high performance in logistics. We are currently upscaling this, so we are actually equipping our entire lab with LiDARs, 11 in total, to basically elicit data over all corridors. And basically what we are offering to you is to deploy our system in your factory shop floor for 1 month or 2 months to collect the data. And then you can use that data basically to optimize the transportation routes beforehand. So already during the planning phase, you can say that between 8 and 12, you will take this corridor. Between 12 and 1, you will adjust the route to take this way around so that you can still maintain a high speed. Another usage scenario is that sometimes you have stationary robots, and basically you are having laser scanners and you have this monitored stop approach, where if someone enters the laser scanner field, the robot will stop. The speed of the robot always depends on how much distance do you have in the laser scanner. The more laser scanner field, the wider it is, the higher the speed of the robot. However, currently all of them stop at the corridor edge because you always assume that someone is walking. However, using our approach, you could actually extend the laser scanner field into the corridor if it's a less frequented corridor. So yes, there is a probability there that someone will be there, but that probability is so low that the higher robot speed will basically give you a higher robot cell performance and more efficiency in your production process. User scenario C is you can also use this real-time published information about the heat map, where are the humans, to actually do some real-time routing of the AGVs. So we provide the information, the actual real-time routing has to be implemented by you, but in principle, you could actually use it. And finally, usage scenario D. So we classify the corridors into 3 different categories. Green, basically, no one uses it. You can run the AGV routes there without any problems. Red ones, high traffic, foot traffic, you should avoid it. And there is like a category in between where we say you could use it if there is no green route. However, we would then recommend that you add some human detection at the edges of that corridor so that you know basically when it is occupied. The technology for human detection, I think it will be presented in the next presentation. This concludes my presentation. My email is here in case you have questions. Otherwise, please question now.